pretty intense. Well, it's just there's just tons and tons and tons of vocabulary. It comes at you kind of quick. It's going to assume that you remembered everything from 8th grade. When you actually did this, you did this in 8th grade. It will present slightly more challenging problems than 8th grade, but it literally is exactly what you did in 8th grade. They're just going to throw some vocabulary at you really, 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 really quick.
Why do they have to do this?
This is also the shortest chapter in the book. It's like 5 sections long, and it's just on surface area and volume. That's it. We're going to be done with this. Well, if I go back to this was considering doing PSAT, it's only 5 things. So I was saying by next Friday. So if we're doing here, we're going to be done. Move that back 2 days. We'll be done by Wednesday.
There's no school on Monday. Yeah. Why?
Every month we wanted to have at least one 3-day weekend. I mean, some months have more, but we want to have at least one. And since April didn't have one, we just threw one in. It's not a holiday, official holiday, but it is a day off. Okay, homework 1 through 20 all.
Jeez, can I have a piece of notebook paper?
No.
That's McKinley sitting right next to you.
Hey, McKinley, can I go open that locker over there and get a piece of notebook paper? I mean, cabinet.
Sure.
Thanks.
Don't open up a new packet.
What?
If there's one already opened up, that's fine, but don't open up a new packet. All right, here we go. Prisms. Remember what a prism was?
Yes. Yep.
You can go grab one.
Kind of.
Grab me a prism.
Oh.
Some of those are prisms, some of them are. Go grab me one.
Oh, here it is.
So this is a prism, yes? You agree?
Yep. Yes.
Prism?
Uh-huh.
Absolutely wrong. That's a pyramid.
Oh, right.
Prism.
I know what a prism. That's also a pyramid.
No, that's also.
This is called a.
Oh.
This is called a.
Rectangular pyramid.
Oh.
And this one's called a.
Triangular
The
pyramid.
thing in Ben's hand is called a.
Dodecahedron.
Let me see if that is a prism. No, that's not a prism.
Dodecahedron.
This is a prism, and so is this one.
Okay.
So why are these prisms and those are not prisms?
They're special.
All.
Because basically, like, you take a rectangle and then you just kind of move it down, and then you connect.
This is not a rectangle. It's a hexagon.
Okay, you take a shape, move it down, and then you connect it.
What kind of shape?
Any shape.
2D shape.
Okay, so then therefore this is a prism.
No.
You said take a shape, any shape, and move it straight
Any
down.
Polygon.
So take a polygon and do what with it?
You make another one identical to it.
And
That
then center
is-
them with
That is
nothing.
perpendicular,
Parallel.
sir. Parallel. Yeah.
And then,
And then you connect the vertices.
You connect
and when you connect the vertices, what do you connect them with?
Lines.
No, look.
Planes. Segments.
What's the shape?
Rectangle.
You connect the tops to the bottoms using rectangles. That parallelograms more precisely, but that's what makes prisms.
Sir.
Yes.
The easier way to say it could be you have two identical shapes on top.
Now you got to put the word polygon.
Because
because that's a cylinder, not a-
Identical polygons on a plane, and then on two separate planes
Two
below
parallel planes.
parallel planes, with the two identical polygons parallel to each other.
Oh.
Well, if they're on parallel planes, they're parallel.
And then you just connect them.
Now, one interesting thing, these are special types of prisms. There's others that you didn't get exposed to those in 8th grade, but you will today. There's different ones, and that parallel thing doesn't change, but we're going to modify it slightly. All right, we're going to be 2 things this chapter, both surface area, that's 2D. That's how much space is just on the surface. If I were to paint this, where would the paint touch? The paint wouldn't go on the inside, it would only go on the outside. That's going to be an area, not a volume. That's going to be an area, so it's going to be in square units. The second thing, we're going to take every shape that I got up there, and we're going to calculate volume. And obviously that's 3D, so in cubic units. Good news, bad news. Surface area is a butt kicker, right? It is the worst of the worst of the worst. The formula is really easy to look at, but it's not the real formula that we'll actually use for each individual shape. You'll see why here in a second. Volume is the pretty easy one. All right, so lots of shapes in this chapter and formulas for everything as usual. Just make sure you have it in your book of truth. You'll be okay. Everything we do, just like last chapter, it's just a plug and shove. You get what's the shape? What am I doing? Volume or surface area? You take the dimensions, you plug them in, and you're done. So here we go. I thought that maybe this was what he had in his hand. This one actually is not a prism.
That is not a dodecahedron
But the
either.
first thing we're going to talk about before we talk about prisms, do you know what this was actually called?
What? Okay. Well, so dodecahedron.
No, I mean just the general. What is it? I don't want the specific. But,
Soccer ball
hey, this is made up of pentagons
and
hexagons. Okay, and yeah, if you round it around, it does make a soccer ball. These are called not polygons. Polygons are 2 dimensions. These are called polyhedrons. Write that one down. Polyhedrons. So it's the same idea of polygons, gon meaning corners, but these are ones that have many sides. But the sides are made up of polygons. You can't make it full of circles or something like that. It's got to be made up of polygons. Any type of polygon. They don't have to all be the same like this one. This is made up of pentagons and hexagons. But if you're a polyhedron, you are, well, 3 dimensions. Made up of polygons. The polygons are joined at their edges. Today we will be talking about a specific type of polyhedron. Today we'll be talking about prisms. So prism, well, it's a polyhedron, and you guys have already said it. It's got to be 2 identical shapes, and they have to be parallel to each other. And then you connect the sides with, or you connect the edges of the 2 parallel polygons with parallelograms. In 8th grade, we didn't say parallelograms, we said rectangles, because notice each one of these are made up of rectangles. A rectangle is a parallelogram. You're going to see here in a second why we can't ever again use the word rectangle. Anybody know why?
Because wouldn't it technically, isn't it just a bunch of planes stacked on top?
Yeah, I mean, they do inhabit planes, right? But I'm saying why? I mean, it certainly is a rectangle. Those are certainly rectangles, but why did they change it from rectangles to parallelograms?
because you could have it parallel here and here.
And that's the reason. We have a name for that. We're going to write that one down.
They could also be perfect squares.
Then you get a cube, right?
But then you have rectangles.
But that is a prism, right?
Yeah.
So this is what we were trying to describe there with words. So you can, at least in 10th grade, or geometry, high school geometry, we now can separate ourselves from these and consider any prism. And any prism, the 2 congruent sides absolutely have to be parallel, but they don't have to be stacked, as you're using your verbiage. They can be offset like this one right here. All right, so this is box 2. It's got a lot of stuff to write down. Lots of, I mean, I'm going to fill this whole thing full of words. So we're going to do one piece at a time. All right, the first one is the base. The base are those 2 congruent polygons, right? They are parallel to each other, and they are what gives the shape its name. So for instance, this is what's the shape? So this is a hexagonal prism. I almost said polyhedron. It is a polyhedron. So those are the bases. There's always be 2 of them on a prism. There is one specific type of prism where you can have 6 of them, and that's there's one specific where you get 6 of them.
6 of what?
6 bases.
You get a cube.
In a cube, right? Now you might argue, well, you can take a rectangle. This is actually, if you turn it this way, it's a square prism, right? But the height of it is not the same as the dimension of the base. If I turn it this way, well, then this is your base. So this one is rectangular prism, and you can argue, well, that there are 6 rectangles, but a cube actually has 6 of the same shape. No matter which way you turn it, it's the same shape. So, but as soon as we get to this, well, you get 2 of the parallel ones, and then the other ones are all parallelograms. In 8th grade, they focus, in 7th grade as well too. They love to. This is the hardest one to have kids. If they were just to show this one, kids would get prisms all the time. They show this one, it's like, well, which ones are the bases? Well, doesn't matter. Base is on the bottom, the base is on the side, the base is on the top. But this one, the base has to be the 2 hexagons. All right, next word. Now we're moving into weird stuff. Lateral face. Lateral means side. The lateral faces are those parallelograms. Lateral faces are the parallelograms. Lateral face. And if it's a hexagon, there's 6 of them. If it's an octagon, there's 8 of them. If it's a rectangle, then there's 4 of them. Can you have a triangular prism? And then there's 3 of them. I don't have one of those. Is there? Do I have one? I didn't think I had. Oh, I do. What do you know?
So technically, I was partially right.
Oh, no. You said this was a prism, so and you all agreed, by the way. So you weren't the only one that was wrong. So there we go. There's all my. There's one where there's a square one down there, but these are all my prisms. Okay, next
I have
word.
a question.
If we think about, here's your prism. We think about the parallelograms where the 2 parallelograms join together, not on the bases, but on the 2 faces joined together. Those are called the edges. Okay, lateral edges. The lines that connect the vertices of the bases. That's confusing, but that's exactly what it should say. The lines that connect the vertices. I can take out that second word, vertices. That I don't need to have that. That is, I think I did make a mistake there. The lines that connect the vertices of the bases. Yeah, don't put that extra word there, vertices. That's messed up. Let me change it.
Full of good ideas today.
And you can see the last word, the perpendicular distance between the 2 bases is called the altitude.
Where have I heard that?
Notice we don't call it height, we call it altitude. You can call it the height, but we call it the altitude.
First time mathematicians aren't lazy with their names. Right.
Now just be careful. They start talking about edges and not lateral edges. And they're talking about literally all the places where the shapes come together. That would include the bases. But if they say lateral edges, they're just talking about the ones that go around the side. But they talk about edges, well, this is also an edge right here, just not a lateral edge. Okay, got everything written down? All right, parts of a prism, box 3. So what kind of prism is this?
Triangular.
Triangular prism. All right. This is called a right triangular prism because where the lateral edge meets the base, it forms a right angle. A requirement to be a right prism.
You must be this tall to be right prism.
There you go. So right prisms. Those whose prisms whose lateral faces are rectangles. Not parallelograms. Well, okay, that's not precisely stated. But the parallelograms are rectangles, not the other way around. So that means any one of the lateral edges, since we measure the altitude perpendicular between the 2 bases, any one of the lateral edges is also the altitude. We're used to measuring height or altitude from the middle of a base, but you can actually, as long as it's a right prism, you can measure it along its lateral edge. Does that make sense? And it's because it's a right angle. Now notice we're drawing this all in 2 dimensions. It's a 3-dimensional shape. So your eyeball can do really weird things on some of these shapes.
Of course, my eyeball can never do anything right.
We generally, if it's something that you wouldn't normally see, if it was a physical shape from you, would make it dashed, indicating that you would not typically see it. All right, so the altitude is right there. How about this one right here? Well, first off, we got to give it a name. This is a prism. I've got 2 pentagons. They're parallel to each other. They're not one above the other. They're offset a little bit. We call this one an oblique prism. Notice now the sides are no longer strictly rectangles. They're still parallelograms, but they're not rectangles. So how are we going to measure the altitude of this thing? We can't measure it along a lateral edge.
Draw the 2 planes and then do an altitude from
And you know where they typically put the altitude?
In the middle? Outside? Like
It can be, but
most
there's so many
obscure
lines that
spot
they
possible.
generally put it outside. Okay,
It's like a truck.
I'm not sure why that arrow is pointing there. That's wrong.
Altitude.
I know why, because I changed the slides earlier and I didn't move the word altitude, but I know why I did that.
Hey, Jack, are you hungry?
Nope.
Come here, arrow. Where are you?
I'm hungry for donuts.
You might have one.
Well, apparently that altitude arrow's stuck there. I'll have to fix that for next year. Okay. All right. So the first thing we're going to do is we're going to take these prisms and we're going to calculate the surface area. Remember, that would be the area that covers just the, well, as the name implies, surface. All right. Write this down, book of truth, not necessarily in box 4. It's got to go book of truth. The formula is, okay, there's a whole bunch of letters there. They don't mean anything. TA equals LA plus 2B.
What the heck?
That is the formula for surface area of a prism.
Wouldn't
TA, what's TA?
I know, I got to explain all that stuff.
I can get what 2B is, but
What's 2B?
probably 2 times the base.
No.
no?
2 times, obviously, but not base.
I got the 2.
Let's see.
Notice it's not it's a capital B. Notice that all of these are capital letters too.
It's not, I know A is altitude. T is trigonometry.
Yeah, it's not that either.
T is
If-
trigonometry.
If you're looking at the book, then you don't count
No, I'm looking at the homework, but I know what those are.
because you looked at the book. Okay, so
What?
let's write this down. I'll cover TA the last thing. LA stands for lateral area. And remember, lateral would be the sides. So we got to first calculate the area of the sides. That makes sense, right?
That's what base times height times.
Well, is it a parallelogram or is it a rectangle? By the way, what's the formula for area of a rectangle? What's the formula for area of a parallelogram?
Base times height.
Okay, well, that's convenient.
2 convenient. Yeah, 2 convenient.
The area of the lateral faces of a prism, abbreviated LA. Capital letter B doesn't stand for base, it stands for, go ahead, Ben.
Capital letter B.
Capital letter B.
I don't know. I knew what T A and L A mean. I have not looked at the book,
All right.
but I will look at
Capital
the
letter
book.
B stands for the base area.
Oh, yeah, I remember that.
The base area.
This is
sir.
also why in 7th and 8th grade, since I had you for 8th grade, I told you the formula for volume was capital BH, and I said, let's not use that formula because everyone will just be using the base, and it's wrong. It's base area. So it's the lateral area plus Y2.
Because you have 2 bases.
I got 2 bases. All right. Well, I mean, notice I've just given you a formula without proof, but we don't need proof for this
We
one.
could
I mean,
say
it's
a
the lateral area plus the 2 bases. That there's nothing left on that shape for surface area, so we choose not to prove this one. Lastly, TA. I don't know why I put this. Every other book I've ever taught from, surface area was abbreviated SA. Our book abbreviates surface area as TA for total area. I'm just going to say, be flexible, right? I've not seen too many books that have ever used TA for surface area, but this book does. And I guess what the point they're trying to make is total area includes the surface area of many things, the base area and the lateral area.
In the surface area. Why don't they just say surface area?
That's the way I've always done it. But they tonight for homework and into the chapter, whenever you see TA, they're talking about the surface area of the shape. Total area. All right, we okay?
Yeah.
plug and chug now.
Plug and chug.
Yeah.
Now, notice this isn't a very useful formula because, well, it's
You gotta
clearly
figure out the area
between these two, it's a whole big difference. And by the way, one of these could be oblique too. Okay. So you're going to have individual formulas for depending upon which one you have, but it's not as bad as you think. All right. So TA total area. All right. So here's the actual formula to figure out the lateral area. The lateral area is the only hard thing to figure out.
That's really dumb because that's just saying this part of the area plus this part of the area.
I know.
Like that would go without saying.
It would, but how do you figure out the lateral area?
You just figure it out for whatever shape.
Well, one way to do it would be to, well, how many sides?
Four.
How many sides?
Oh, three.
3. We could do 3 times. And these could all be different if this was a scaling triangle, by the way.
Three
It would-
times BH.
yeah, but it could be different if it was a scaling triangle. If it was an equilateral, then yeah, it would be 3 times one of these sides. If it's a scaling triangle, each one of these sides would be different. That would change the rectangle. Then we have to do 3 separate calculations just to get to the lateral area. Smarter person than me figured out an easier way of doing it. All right. Here's the easier way of doing it, right? The lateral area of a right prism, okay? Cut off the sides and lay them flat. What shape would it make? Of a right prism. Cut off the sides, lay them next to each other. What would you make?
Like a really big box.
A really big, I'm laying it flat. I don't make a box.
Rectangle. Well,
I really make a really big rectangle, right? Triangle, if I cut off the side, now right, it's a right prism. So if I cut off the sides and I lay them flat, I make a really big rectangle. Can you see it? See where I got that from? Well, how do you calculate the area of this thing?
Base times height.
So what is the base here?
Side.
Which side?
3 of them.
Which is the base?
The side.
No, where is the base?
All of the 3 top ones combined.
Okay, I'm going to choose bottom, but yeah, top will be fine. It would be these 3, right? Now look at the original shape. Where did that come from? Where did this red line come from on the shape?
From the 3 things there.
Triangle.
What part of the triangle?
The bottom. Base.
The what? No. Where did this red line represents the length of the, Big
sides,
rectangle.
The sides of the triangle.
and we call that the,
The sides of the triangle.
we call that the,
Sides of the triangle. I'm just gonna keep saying it.
no. When you measure all the sides of the triangle, you have measured,
Your area.
no,
Perimeter.
the perimeter.
Perimeter times the height.
So it's the perimeter of the base. Now, I just chose that, but that would be the same for this shape right here, right? If I take all the sides and lay them flat, that would be the perimeter of the base, right? So it's the perimeter of the base. You said big rectangle is base times height. What's the height here? That would be that part of it. Where does that come from?
Lateral sides.
That comes the altitude of the prism. Remember, it's a right one. Altitude of the prism. Okay, cool. So lateral area, we could write easily more distinct as the perimeter times the height. Now, we don't use the letter A for altitude because A was apophyte. Okay. All right, so this is actually theorem 12 plus 1. It says the lateral area. Now, notice this only applies to right because if it wasn't right, then we would have parallelograms. Okay. Lateral area of a right prism equals the perimeter of a base times the height of the prism. So pH. That's just lateral area.
Of course, geometry has to be complicated.
Now, P stands for perimeter and H stands for altitude. All right, so we're getting closer to being able to use the formula. Pretty much that's good for the formula because all we're going to do is for the 2B, just remember the capital letter B stands for base area. Now, remember, that's going to change. By the way, this can get exceedingly more challenging because now you know how to calculate the area of any regular. Notice that's why we're going to stick to regular prisms. You know how to calculate the area of any regular polygon using what formula?
A
Last test.
AH over 2.
You sure it's over 2?
AP over 2.
AP over 2. Okay.
Oh, I hated that formula.
Which someone in this class forgot.
No, how dare they? Oh. Hey, that's not fair.
This was divided by 2. He got the A times the P, but
I knew what LA and TA meant. And
I'm talking about last test.
Oh,
Remember you forgot to divide by 2?
yeah.
Okay. So surface area formula, if you want to write this down somewhere in your book of truth, this would be it all. This is the one that you really want to use right here. You want to use pH plus 2B. Now, why can't they say that? I don't know. It seems ridiculous to me. Like, well, why did you tell me it was lateral area? And the reason why is because that applied to all prisms, not just right prisms. But this is for right prisms.
Substitution.
Well, no, the rest is just plug and chug. They're going to give us some. They're going to give us some values. Now it is high school geometry, so they're not going to make it nice and easy for you. Sometimes they're going to give you other information that you're going to have to use to figure out the values you actually need. But it's not too bad.
That feels like they're scamming you.
It does. Well, I mean, like I said, you're not in 8th grade anymore. P perimeter, altitude, base area, if you need to write those down. If you're going to make a mistake, you're going to think that means base, and then you're going to put some nonsensical number there. It's base area. All right, let's do one. Total area is equal to surface area. Total area is equal to lateral area plus the base area. Here we go. Oh, box 5. What's the shape?
Right. It's a pentagonal prism.
It's no, it's not.
It's a prism.
It's
It's definitely right.
Oh, it's a quadrilateral prism.
More specifically,
It's a
what's the shape of the base?
trapezoidal prism.
So it's a trapezoidal prism. All right, Ben, you got to do this. All right, trapezoidal prism. So if we want to calculate the total area, hint, hint, that means surface area. If we want to calculate the surface area, we use our surface area, total area formula. Okay, what do we need?
Base area.
Well, if we go left to right, where you need the perimeter, right? And you could do base area as well, but we need the perimeter. So what's the perimeter of the base?
So 10 plus 12 is 20. Yes.
Okay. 28, okay. So we get 28, oops. The height is clearly, or the altitude is clearly 10. And remember, that's only because it's right. If it wasn't right, we couldn't use the lateral edge to find the altitude. Okay. Now we need base area, which means we need to go back a chapter and remember the formula. What was the formula?
Height times the base 1 plus base 2 over 2.
Okay, remember that? I wouldn't have said it that way, but yes. Sum of the two bases times the height divided by 2. So what are the two bases?
6 and
6 plus 12.
18.
I'm going to take half of that before. I don't want to multiply. Half of 18 is?
6,
9.
9.
And what's the height of the trapezoid?
4.
So therefore it's
36.
36. Okay. And there's all that. So I throw that into the B, and the rest is pretty simple. Okay. So that's 280 plus what? 280 plus 72. So 352. Is that right?
Yep.
And if you're going to make a mistake, it's because the very next question will be calculate the volume, and they're going to ask you total area, and you're going to forget that you're doing area instead of volume. So it will be in units squared. All right.
What if I don't want it to be in units squared?
Well, then you better be calculating volume.
Hard to use they though. Why do you have to say they?
Well, I'm publishers of the book. All right. Now, notice how many examples did we just do?
1.
Welcome to high school, right? They expect you to be able to grasp this entire concept with one problem. Is that true?
Yes. We got
Okay.
scoring in 8th grade.
All right. Now we're going to switch immediately to volume. I showed you this in 8th grade, and I said volume is literally how many cubes can fit inside the shape. Count how many cubes, that's the volume.
I know how
So the definition of volume is the amount of space in a 3D object expressed in cubic units, but literally they're saying like count the cubes. Each cube is some unit by some unit by some unit, and all those sums are exactly the same. It's a 1 by 1 by 1 cube. Okay. All right, so Theorem 12.2 gives us the formula. Okay, who's the smarty pants can tell me the formula for a prism for the volume that hasn't looked in their book?
base area times the height. If it's a right,
If it's a right, it's going to be
base area times the
base
height.
area times the height. Okay, write that one down. And this was the one that in 8th grade I also said I didn't like because it's okay, it's true, but I mean, it's a different formula for the triangular prism versus the hexagonal versus the rectangular because the base area changes. So it's a true formula, but it's like you just gave me step 1 of a 5-step procedure, but I really need step 2 to make any progress on it. Because the base area changes whether it's trapezoidal or whether it's triangular or rectangular, hexagonal, pentagonal.
I wonder how the other people in the other class are thinking about this right now.
I didn't make them do it today because they're not the honors. So I was going to say, I'm going to start this with the honors. I'll give the other kids. They did so badly on the, oh, this is being recorded. They did so badly on the factoring a quadratic that I was like, I'm going to review quadratics with them.
Oh, in the,
Because they didn't get any of them right. I mean, it was like one kid, and I had to walk her through solving a quadratic, but like there was way too many people that missed it. I'm like, man, there's going to be nothing but quadratics on this PSAT test, and you guys are going to not get them right because you're in geometry, not algebra 2.
But we got them right.
You guys got them all right, so I'm happy with that. Okay. Capital B once again stands for the area of one of the bases, and the H is your altitude. All right, so back to the one that we just did, we're going to calculate the volume. So what do we need?
base and height.
And we just calculated the base area. What was the base area? It was 36, so we need to multiply that by, okay, this one isn't bad at all.
360
So it's 360, what?
centimeters cubed.
Centimeters cubed. Okay, cool. All right, that's an 8th grade one right there. Let's do a high school geometry.
Oh, no.
Oh, by the way, you never in 8th grade calculated the surface area of a trapezoidal prism, right? You only did rectangular ones and triangular ones. That was it. But you certainly calculated the volume of this one. That was an easy one to do. All right, so the more challenging ones are it's going to be the same shapes. They're just going to choose to give you a various amount of information. Sometimes they may give you the volume when they want you to calculate the surface area. You're going to take that volume formula, and that's what you're going to derive the other pieces parts from. For instance, this one, they're going to give you the volume, but not the height. Well, you're going to be able to calculate the height from the volume. So let's see what this looks like. First off, this is a
Triangular prism.
triangular prism. They left off the right angle, but it's right.
You also left out the volume.
Left off the what?
Yeah,
Yeah,
yeah.
on our sheet.
On your sheet, I didn't put volume?
Yeah.
Okay.
How
I
can
got
you do this to us?
I got to do that. All right. So the volume is
I got
315
solid
cubic units. And it says calculate the total, once again, code words for surface area. So we're going to calculate the surface area of a triangular prism.
So you just do 10.5 times 4 divided.
Well, first off, what's the formula?
Oh, base times height, but for base.
What's the formula for surface area, total area? Look at your sheets. What's the formula?
Perimeter times height plus 2 times the base.
Okay, so perimeter times the height plus 2 times the base.
Base area.
Base area, correct.
You don't need to do that.
Yeah, but we're not calculating the volume, we're calculating the total area, surface area. Okay. All right, so first thing I need is the perimeter. Can I get the perimeter from here? Of the base, by the way.
Yes.
What's the perimeter?
7 plus 6.5, 13.5, 20, 21.
10 plus
No, 24.
24. Okay, so we got a perimeter of 24, right? What's the height? Don't know.
4.
Where are you getting that? No, the height of the thing, it's H.
Oh, yeah.
And I guess we could fill in B. B is what?
Is 24 times 4 divided by.
It's the base area of the
So it's 48.
triangle.
So it's 48.
40,
I heard 48 and 40. Which one?
42.
I'm getting 42 is what I'm getting.
Yeah.
Okay, I just got
4
two.
times 5, 20, carry 2.
Wait, 5. Oh, yeah. Wait. Was you have to divide by 2?
Yes, so therefore
Oh,
So therefore it's 21.
it's 21. Okay.
yeah. Okay.
So the base area is 21. All right, if you didn't understand what we're doing, that's what we're doing. So 21. Okay, well, how are we going to find out the height?
Plug it into the volume.
And that's the key here is they also gave us volume. So what's the formula for volume?
21 times 8.
Base area.
Base area
Times
times height. So I would say 315 is equal to
21H.
21H and then solve that equation. So right here,
So it's 15.
is it? You did calculate? Okay. So height is equal to 15 and then you can take that and plug it in. There you go. So there's a high school level formula for either volume or surface area. Okay.
I've seen worse.
Yeah, this one isn't too bad, but expect this tonight for homework that it's not going to be, a couple of them will be very easy, but some of them you'll have to hunt and choose for your values. All right, so 402. Let's look at the table because you guys always you always have questions about the table.
I never have questions. I kind of get the table at some point.
What page of it was the homework?
On the page is 478, 479. No, just 478. 478.
478. Table. McKinley, look it over. And I gave you what, 1 through 20? Was that what I gave you?
Yeah.
Yes.
All right. Pick anything on the table you want, McKinley.
Well, what do I want? I want a hot dog. But, number
Hot dogs are the cylinders. Actually, we're not doing hot dogs, but we are doing cylinders later
That
on.
was the look.
Pick one, McKinley.
I chose 6.
Number 6. All right. So what's the shape?
It's a rectangular prism.
Rectangular prism with length, width, and height. All right. So we have a rectangular prism, and the question marks are on LATAV. So LA is
LA is, where's the formula? Dang it, I closed the book.
what? Lateral area, and the formula for lateral area was LA is equal to perimeter times the height. So what's the perimeter? You got length, width, and height.
Is W times.
Be
2
careful
and
on
H
this.
W times 2 and H times 2.
Yes. Wait, you said W
No,
times
times
2
two
and
L times.
L times 2, yes.
But you could do it either way. I mean,
So it's
Not H. Oh, if you turn it on the side, yes, you could do that.
so it's 20.
You agree with what she said, 20?
Yeah.
You agree with what she said, 20?
yeah.
You agree with what she said, 20?
12 plus 8.
Where are you getting a 12 from?
Multiplying it
6
both by 2.
times 2.
Where are you getting a 6 from?
The length.
Where are you getting a 6 from?
The length.
The length is
My goodness.
I'm getting 5x is the length. Which ones
Why
are
are
you
we
looking
doing
at?
6? We're doing 1.
She said number 6.
Oh, okay. so
Hey,
it's-
she. I'm a guy the last time I checked.
Sorry, I'm misgendering you. All right.
he identifies as a
Misgendering.
man.
Is it 20 for the one you guys were doing?
Yeah,
Yeah.
for 1.
Okay. All right. Now it makes sense. I'm like, where are they getting this from? So we're doing number 6. So
That's 8x.
it's what?
18x.
Thank you. All right. So the perimeter is 18x, and what's the height?
And the height is 3x.
So therefore,
It's
ugh,
40,
Oh.
50.
54. Is that right?
Yeah, 54x.
54
X squared.
x squared. There you go. So that's what your height is. All right.
No, not height.
That's your lateral area. Sorry. Lateral area. I even have it written right there. Okay. Now what are we gonna do? Total area. Total area is lateral area plus base area. Now we're going to consider the bottom of that, the very bottom of that, the base. So what's the base area,
L times W.
right? Which would be,
20x squared.
so we get 20x squared plus,
54x.
and I wrote that backwards, but it should be 54x squared plus thing, but that's pretty simple.
So you get 74x.
You get what? 74x squared. Okay. And that would be in units squared.
That's total area.
How about volume?
Is lateral area
No,
base area times height.
base area times height. And we said the base area was 20x squared and the height is,
2. No, 3x. Sorry, keep looking on.
therefore it's going to be,
Times 60x cubed.
and it's got to be cubed because obviously it's,
You add.
all right, well, that wasn't too bad. Anna, pick one from the yellow or whatever color that is.
Yeah, Anna, pick one from the yellow.
9.
All right, let's do number 9. Number 9. We have, is it a cube? Yeah, it's cube, E. All right, so it's cube. On number 9, all it's given us is the volume. So we know volume is equal to capital B times
H.
H. And what do we know here?
Well, the volume's 1,000.
Okay.
For 9.
Yeah, for 9, the volume's.
Do we know the base area?
No, but
We can just divide it by 3. Divide it by, square root of 3, which is 10.
Well, we do know it's a cube, so what do you want me to do?
divide by 3.
Why divide by 3?
No, square root 3.
Cube root.
Cube root.
Ooh,
That's what I meant, square root.
cube root.
That's what I meant.
So what would be the cube root of 1,000?
10.
So what does that give us?
It gives us 10.
But what is that?
It's the GH. No.
So
No, it gives us H.
So what you wanted to
It
do
gives
was
us
you
H. It
said
gives us
that,
H. It gives us H.
you said BH and then you wanted me to
It gives
take
us
the
H.
cube root of
It
everything?
gives us H. It gives us H.
I think he's saying.
We gotta think this one over.
It gives us H.
We gotta
It
think
gives
about
us
this.
It gives us H.
But I'm saying,
No, it gives us
if
both.
you took the cube root of
It gives
everything,
us H.
you would also be taking the cube root of a capital letter B, yes?
I'm just gonna do this without you.
All right. Well,
No,
here's the key.
because you're figuring out one side.
You are. But I know,
Hey.
but I'm saying you told me to take the cube root. So if we follow your logic, you can't just take the cube root of one of these letters. You take the cube root of everything.
You're not cubiting that equation.
Okay, so now tell me algebraically
You're
what you want me to
cubiting
do.
That to figure out H, because H times 3, H to the power of 3 equals V, and V equals 1,000.
I'm not arguing with the answer is 10. I'm just arguing with what you wanted me to do because
So
this
then
would,
just put 10 in for H. I'm not using that equation. I'm using a different equation.
what equation are you using?
I'm using H cubed equals,
Why would you be using H cubed?
because
I'm
H
doing a teacher
squared is
thing.
the base area, and H,
Oh, we've stumbled upon it. All right, and the
Yeah.
reason why is, well, it's a cube, so how would you calculate B?
E squared,
You would take the side length and do what with it?
squared.
You would multiply it by itself. Doesn't matter what the B is. It could be E, it could be Z, it could be PDQ, whatever, right? Whatever it is, it's going to be times itself. And then what do you notice about the measurement of H?
Gotta be 10.
No, what's the measurement of H? Is it any different than the length or the width?
No.
It's the same. So here's how I would solve it, right? Assign a variable to one, it could be E, right?
Why are you doing this? It's so easy.
I know it's easy. I'm explaining why you are allowed to take a cube root. You're allowed to take a cube root because all three measurements, length, width, and height, are the same value.
Because you're not using
E,
B,
A,
you're
C,
using
whatever you want to make it. I make it X, so therefore it'd be X times X, length times width, times height, which gives me X cubed. Now, algebraically, it is true that I can take the cube root. Because up here, if I take the cube root of this, that doesn't wind up with, That doesn't do anything.
I was just being ahead of you.
Oh.
so now I can take the cube root of both sides and I get that X is equal to 10. Therefore, each side length is 10. And what else do we need? We need total area, which is pretty simple. TA is equal to LA, which is, LA is
PH.
PH plus 2B. We already know that that's going to be what, 200? Am I right? That's going to be 200. B, X times X, or 10 times 10 is 100 times 2. So we get 200 here. The perimeter, if it's one side is 10, there's 4 of them.
So it's 40.
So it's 40
40
times
10.
times 10, 400. So it's 400 plus 200, 600. And that would be in units,
Units, yeah.
square units. And that was number 9.
0, 0, 0, and 6. Yay, I did it easy.
And that's all we got time for. All right. Like I said, it's going to be like drinking from a fire hose, this chapter. It's going to come really quick and formulas galore every single day. You have seen these formulas in 8th grade up until, let's see. Actually, I'm not seeing any formulas we haven't seen. 12.5 maybe?
So all I have to do is tell her back to 8th grade, watch it a few days, and then come back. And
12.5 is weird stuff, but all the way up to 12.5, it's stuff you've seen before.
Yes, I will lock my bathtub in the locker rooms, and then I will watch and pretend I'm 8th grade me.
Or you could join the other 9th graders.
Only though.
No. I don't want you picking up any bad habits.
Hey,
Hey,
I have a lot of friends in that class.
Do you want to do me a favor? I went to bring the t-shirts up and I forgot them. Would you be, do you have time to so you can get them out?
I think Ben and I'm
Are you
leaving.
Would you be up for that?
Yeah, math. Math can.
And something called
Also,
identification.
who called
Could you do me
dedication?
a favor now then? Could you do Dylan